The ratio of the number of molecules in 2 grams of hydrogen to that in 16 grams of oxygen is dash. Solution. Before we proceed, if you are yet to subscribe to this channel, kindly do that, and as well click on the notification bell so as not to miss out on more videos like this. There is a link to our Telegram channel in the description box, which is also being displayed on the screen right now. You can join our channel via the link for better communication. Now back to the question. We are being asked to determine the ratio of the number of molecules in 2 grams of hydrogen to that of 16 grams of oxygen. So the first thing to do here is to calculate the number of molecules present in each of the elements stated, that is hydrogen and oxygen. And to do that, we'll be using the formula that states number of entities equals moles, that is the number of moles, multiplied by 6.02 times 10 raised to the power 23 entities. Divided by 1 mole. The word entities here refers to the state which the element can occur. It can be atoms, it can be particles, it can be molecules, and it can be ions. Whilst the constant 6.02 times 10 raised to the power 23 is being referred to as the Avogadro's constant, and some do call it Avogadro's number. Now this is the formula we'll be using to determine the number of molecules present. Here in this case, our entities will be replaced with molecules since we are dealing with molecules. Now what we need to know to apply this formula, the next step is to determine the number of moles of each of the elements, and we'll do that by using the formula moles equals mass over molar mass. So let's continue to determine the number of moles present in hydrogen now. So we see molar mass of hydrogen. As a molecule, hydrogen is represented with H2. So that is 2 multiplied by 1, which is the atomic mass, and this gives 2 grams per mole. Then the number of moles of hydrogen. Number of moles is given as mass over molar mass. So the grams, we have 2 grams divided by 2 grams per mole, the molar mass we calculated, which is equal to 1.0 moles. Okay, so with this, let's continue to determine the number of entities as well. Then we know we are done with hydrogen, while we'll be left with oxygen. So the number of molecules of hydrogen our mole, which is 1.0 multiplied by 6.02 times 10 raised to the power 23 molecules divided by 1 mole, and this gives 6.02 times 10 raised to the power 23 molecules. So with this, we can say that in 2 grams of hydrogen, we have 6.02 times 10 raised to the power 23 molecules present in it. Let's proceed to do that of oxygen to calculate the molar mass of oxygen, the number of moles, and the number of molecules present as well before determining the ratio. Molar mass of oxygen. represented with O2, since we are dealing with molecule, will be equal to the number of atoms 2 multiplied by the molar mass of oxygen, which is 16, and this gives 32 unit grams per mole. While the number of moles of oxygen will be the mass, which is given as 16 grams from the question, divided by the molar mass, we've gotten to be 32, and this equals 0.5 moles. So for the number of molecules, the number of moles 0.5 multiplied by the number of entities, molecules, divided by 1 mole, and this equals 3.01 times 10 raised to the power 23 units molecules. So we've gotten the number of molecules present in both hydrogen and oxygen. The next thing now is to determine the ratio of hydrogen to oxygen. And then be equal to the number of molecules present in hydrogen, which is 6.02 times 10 raised to the power 23 molecules divided by that of oxygen, which is 3.01 times 10 raised to the power 23, our unit molecules. Dividing this, we have 2/1. Next, we can say the ratio of the number of molecules in hydrogen to oxygen is then equal to 2:1, that is 2:1, and this will be serving as the final answer. Do not forget to subscribe and as well click on the notification bell so as to be notified as soon as new videos have been released. There is a link to our Telegram channel in the description box. You can join our channel via the link for better communication, and as well leave your comments in the comment section below. Thank you.